Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to discuss another problem. So let me write today's problem. It goes like this. A particle moves in an XY plane in such a way that its X and Y coordinates vary with time according to x of t is equal to t cube minus 32t and y of t is equal to 5t square plus 12. Then it is given that here x and y are in units of meters when t is in units of seconds. Then the problem says find the position, velocity, and acceleration of the particle when t is equal to 3 seconds. So this is our today's problem. Let me check it before moving to the solution. Particle moves in an xy plane in such a way that its x and y coordinates vary with time according to x of t is equal to t cube minus 32t and y of t is equal to 5t square plus 12. Here x and y are in units of meters when t is in units of seconds. Find the position, velocity, and acceleration of the particle when t is equal to 3 seconds. You can see this problem pertains to motion in 2 dimensions, and you know that motion in 2 dimensions, we represent position by a position vector. Velocity is also a vector, and acceleration is also a vector. So this problem tells us to find that position vector, velocity vector, and acceleration vector of the particle at t is equal to 3 seconds. Right? So let us move to the solution. Now, since the motion is in xy plane, so particle has x coordinate and y coordinate, and those coordinates are changing with time according to these functions. So if I have to write the position vector, we represent that by r. So let me use some other color. The position vector for the particle is given by. Now this position vector will be function of time, and it will be x of t I cap plus y of t j cap. You can see the coordinates of the particle become the components for its position vector. X is x coordinate of the particle, y is y coordinate of the particle. They are changing with time according to the given equations. So the position vector is time dependent. So let us substitute for x of t, which is t cube. Let me use another color. T cube minus 32t I cap plus y of t is 5t square plus 12 j cap. X of t is t cube minus 32t, y of t is 5t square plus 12 j cap. I hope you got it. It is easy. Position vector gives the position at all times. Its components are the coordinates of the particle, and coordinates are time dependent. They depend on time according to these equations. So we have written general position vector for the particle. We are asked to find the position at a particular instant t is equal to 3 seconds. So we have to put t is equal to 3 seconds and solve for r. So let us do that. At t equal to 3 seconds, what is our position? So put t is equal to 3 seconds, it will become minus 69 I cap plus 57 j cap. So this is the first answer. How I have done it? It is simple. I have to put t is equal to 3 seconds in this expression. So it will become 3 cube minus 32 times 3, then I cap plus 5 times 3 square plus 12. So when you do the calculation, you check it. I have substituted t is equal to 3 cube minus 32 times 3, then plus 5 times 3 square plus 12. When you do the calculation, it turns out to be minus 69. This thing is minus 69. this thing is 57. So the position vector at t is equal to 3 seconds is minus 69 I cap plus 57 j cap. Now the components will have units of meters because x and y are in meters. So let me write it where the components are in units of meters because x and y are in meters. So this is position at t is equal to 3 seconds. So this is one part of the answer because we are asked to find position, velocity and acceleration of the particle at t is equal to 3 seconds. Let us move to the velocity now. You know this particle will have velocity along x and velocity along y. So if Vx is the velocity along x-axis, it will be rate of change of position along x-axis. So it will be d by dt of x of t. What's x of t? How position x changes with time? T cube minus 32t. So let us find its derivative with time. T cube minus 32t. When you differentiate it, it will, with respect to time, it will be 3t square minus 32. Vx is the velocity along x direction. It will be time derivative of position along x, which is given by t cube minus 32t. We differentiate it with respect to time. It is 3t square minus 32. So we have solved for velocity along x. I refresh your memory. I have used this formula. D by dx of x raised per n is n x raised per n minus 1. You can see here d by dt of t cube, derivative distributes over addition or subtraction. It is d by dt of t cube, that will be 3t raised per 3 minus 1, that is 3t square, and then d by dt of 32t, 32 can be factored out because you know d by dx of c times x, c is some constant, be c times d by dx of x, that is just c. My c here is 32. So when you differentiate 32t with respect to time, it will be 32 times dt by dt, which is 1. Right? So we've used this. So this is our x velocity. Now we find the velocity along y. Velocity along y will be time derivative of the position along y. So it will be d by dt of y of t, which is 5t square plus 12. 5t square plus 12. So differentiate it. It will be just 10t. D by dt of 5t square plus 12 will be just 10t. How? In first term 5 you factor out, then you find the derivative of t square, that will be 2t. 2t multiplied by 5 will be 10t. And in second term, d by dt of 12 is 0 because derivative of constant is 0. 12 is a constant. So we have find the velocity along x and velocity along y. These will be the components of the velocity vector. Therefore, the velocity of the particle is given by, and the velocity vector of the particle v will be vx I cap plus Vy j cap. What is our Vx? It is 3t square minus 32 I cap plus our Vy is 10t j cap. You can see our Vx is 3t square minus 32. So I have substituted that, and our Vy is 10t. So our velocity vector at any time is Vx I cap plus Vy j cap, which is 3t square minus 32 I cap plus 10t j cap. Of course, it is dependent on time because the components are dependent on time. Now we move to the answer. At t is equal to 3 seconds, what's our velocity vector? We have to simply put t is equal to 3 seconds. Now I hope you are getting it. So at t is equal to 3 seconds, it will be just 3 times 3 square minus 32 I cap plus 10 into 3 j cap. You have to substitute for t equal 3 seconds. It is 3 times 3 square minus 32 I cap plus 10 times 3. So when you do the calculation, the velocity vector turns to be minus 5i plus 30j. Minus 5i plus 30j. So this is our second answer. You can, as always, check the calculations at home. You can see this 3 times 9, 9 3 is 27, 27 minus 32 is minus 5. And 10 times 3 is 30. So it's obvious, it's minus 5i plus 30j. And since x is in meters and t is in seconds, therefore velocity will be in units of meters per second. So it is in units of meter per second. So we have solved two things: velocity at t is equal 3 seconds, position at t is equal 3 seconds. Let us move to now the acceleration. So similarly, we find, acceleration is time derivative of velocity. So acceleration along x, ax, is time derivative of vx. That is d by dt of what is vx? Our vx is 3t square minus 32. This here, or you can see here, 3t square minus 32. So differentiated with respect to time, this is d by dt of 3t square minus 32. It is just 60. Derivative of first term will be 60, second term will vanish because it is constant. So this is our ax. Let us find ay. Acceleration along y direction ay is time derivative of vy, which is d by dt of what is our vy? It is just 10t. So when you find the derivative of 10t with respect to time, it's just 10. But you factor out 10 out of the derivative because it is constant. D by dt of t is 1, so it is just 10. So what is our acceleration vector? Therefore, the acceleration of the particle is given by acceleration vector axi cap plus ay j cap. What is our ax? Our ax is 60. What is 60 I cap? What is our ay? Ay is 10, so it's 10j. So of course this acceleration is time dependent because x component depends on time. So this is our general acceleration of the particle, 60 I cap plus 10 j cap. Now at t is equal 3 seconds, what is our acceleration? For t is equal 3 seconds, it is 6 into t is 3 I cap plus 10 j, so it is just 18 I cap plus 10 j. So this is our acceleration at t is equal 3 seconds. 18I plus 10j. So it is in units of meter per second square. So we have done our problem. Let me summarize it. Particle is moving in xy plane. It is two-dimensional motion. So the position will be specified by two coordinates. Since it is in xy plane, one coordinate is x, second is y. They are varying with time according to these functions. They are given in units of meters, t is in units of seconds. We are asked to find position, velocity, and acceleration of the particle at t is equal to 3 seconds. What we did, we said the position, velocity, and acceleration are vectors, and the position vector in general will be this, because the coordinates will become components of the position vector. Then we put t is equal to 3 seconds to find the position vector at t is equal to 3 seconds. So this is our, let me use some color. This is our answer 1. Then we found the components of velocity. Vx is time derivative of x, vy is time derivative of y. Then we constructed our velocity vector. Then we put t is equal to 3 seconds to find the velocity at t is equal to 3 seconds. So this was second answer. Then we constructed similarly our acceleration vector. Acceleration is time derivative of velocity. So this is general acceleration vector. And we put t is equal to 3 seconds to get the acceleration vector at t is equal to 3 seconds. So this is all for today. I hope you enjoyed this problem. Don't forget to like, share, and subscribe my channel. Thank you. God bless you. Assalamu alaikum.